So here's another nice polynomial problem where we are given a polynomial p of x with the non-negative coefficients. So it simply means that the coefficients are greater than 0 and it has all n real roots. So let's say alpha 1, alpha 2 up to alpha n are the roots. So they all are real. And here is a constant term a of 0 which is equal to 1. So we have to prove that p of 2 is greater than or equal to 3 raised to the power n. So the idea is we're going to rewrite our polynomial in form of its factors. So we can simply say that x minus alpha 1, x minus alpha 2 up to x minus alpha n. So this is our general form of nth degree polynomial. So we know that the all coefficients are non-negative, so we can simply say that the roots inside this bracket must be in positive. So we can rewrite our polynomial p of x is equal to x plus alpha 1 multiplied by x plus alpha 2 up to x plus alpha n. And now we are given that alpha 1 multiplied by alpha 2 up to alpha n is equal to our constant, which is 1. So we are going to use these informations to obtain our result. So first we have to bring our left hand side, which is p of 2. For this we have to put the value 2 inside the polynomial. So we can write p of 2 is equal to 2 plus alpha 1 multiplied by 2 plus alpha 2 up to 2 plus alpha n. And now we can break this 2 in form 1 plus 1. So this is our next clever step. So we can break our 2 in 1 plus 1 plus alpha 1 multiplied by 1 plus 1 plus alpha 2, and it will continue up to 1 plus 1 plus alpha n. And now since we know that in each term we have all three positive quantities, so we can simply use AM/GM inequality to prove our result. So we can simply say that 1 plus 1 plus alpha 1 upon 3 is greater than or equal to alpha 1 multiplied by 1 multiplied by 1 raised to the power 1/3. Similarly, for our next term, alpha 2 divided by 3 is greater than or equal to alpha 2 multiplied by 1 multiplied by 1 raised to the power 3, and it will goes up to 1 plus 1 plus alpha n divided by 3 greater than or equal to alpha n 1 into 1 raised to the power 1/3. And now we are almost done. Just we have to do one thing, that here we got n distinct inequalities, and we just have to multiply them. So by multiplying the inequalities, so what we get, we can say that 1 plus 1 plus alpha 1 upon 3 multiplied by 1 plus 1 plus alpha 2 multiplied by 3 up to 1 plus 1 plus alpha n divided by 3. So we multiplied the left hand side of inequality, and now in right hand side we'll obtain the alpha 1, alpha 2 up to alpha n whole raised to the power one third. And here we can simply say this upper expression is nothing but our p of 2. So we can simply write that p of 2 divided by 3 multiplied by 3 multiplied by 3 n times. So we can say this is our 3 raised to the power n. It's greater than or equal to. Here we can substitute the value that we already know, that the product of roots is 1. So we can substitute the value 1 over here raised to the power 3. So this simply gives us that p of 2 is greater than or equal to 3 raised to the power n. And it's a good place to stop. We are given a fourth degree polynomial, which is x to the power 4 plus ax squared plus bx, it's 3 there, bx squared plus ax plus 1 equal to 0. So this polynomial is itself very unique. You can see that this is a very symmetric about this b. If you see the coefficients are same, so what we have to find the minimum value of a square plus b square, and the condition is given the polynomial has real roots. So first of all we have to work with this polynomial. So we can simply write it as ax to the power 3 plus bx square plus ax plus 1 is equal to 0. And now divide this polynomial by x square. So we can simply say x to the power 4 upon x square plus ax cube upon x square plus bx square upon x square plus ax upon x square plus 1 upon x square is equal to 0. So we can simply solve this and we'll get x square plus ax plus b plus a divided by x plus 1 over x square is equal to 0. So we can simply combine the first and the last terms, and we can take common a, and we'll get x plus 1 upon x inside the bracket plus b is equal to 0. And we can simply substitute the x plus 1 over x whole square. We know this is equal to x square plus 1 upon x square plus 2. So we can simply get the value of x square plus 1 upon x square, which is nothing but the x plus 1 upon x whole square negative 2. So we'll substitute this value over here. So we will obtain that x plus 1 upon x whole square minus 2 plus a x plus 1 upon x plus b is equal to 0. So now we can consider this as y, and we can say that y square plus ay plus b minus 2 is equal to 0. And since we know that this polynomial has real roots, so we can simply say that x has real values, so it simply implies that x plus 1 upon x also has a real values. So we can simply claim that this quadratic equation has also real roots. We can simply say that the d means the discriminant of this quadratic must be greater than or equal to 0. So we can rewrite it as a square minus 4b minus 2 is greater than or equal to 0. So we will obtain that a square is greater than or equal to 4b minus 8. And now here comes the important part of the problem, that this inequality shows that a square has the values which is greater than 4b minus 8. And at the least case we can say that a square is equal to 4b minus 8. And since we know that a square is a positive term, so a square can never be smaller than 0. So a square, so for the least value of a square, it only can be equal to 0. So we can simply say that our 4b minus 8 is equal to 0. So by solving this equation we can obtain that b is equal to 2. And if we reconsider our inequality, so we'll get that a square is greater than or equal to 4b minus 8. And now we will add the b square term in both sides, because we have to find the minimum value of a square plus b square. So we'll get in the right hand side b square plus 4b minus 8. And since we know that b is our 2, then we can simply say the mean value of a square plus b square is 2 raised to the power 2 plus 4 multiplied by 2 minus minus 8. After solving this, we can simply say this is equal to 4. So the minimum value of a square plus b square is our 4.